Hello everyone, welcome to this KANPUR-NPTEL online course on space environment and its effects on orbital spacecrafts. So, in the last module we discussed the plasma environment. We have seen how the plasma environment affects the performance of the spacecrafts. We have discussed the various aspects of the plasma environment. Today we will start the radiation environment. Radiation environment is also to study radiation environment is also very necessary, and we will see that is how the radiation environment also that is the radiation also modifies or it affects the performance of the spacecraft. So, already we discussed the plasma environment. Now, in this session, so this is we are starting today. So, we will discuss what is radiation and what is the space radiation environment, what are the things there, what we should care for about this environment. So, we will tell about what are the different the radiations, what is the origin, different types of radiations are there. So, we will discuss one by one. Now, what is radiation? So, radiation is the form of energy that is emitted. So, it can be in the form of rays or electromagnetic waves or energetic particles. So, all these things it constitutes there is the radiation. So, the spacecraft it can see all these types of the radiation. So, in some cases the radiation can be seen, that is the visible light. So, light you can see by the reflection from the particles or reflection from the object. So, the image is formed in our retina. So, we can see it, but we cannot see the the infrared radiation. So, we can feel it, we can feel that because basically since it is a thermal radiation we can feel it, but there the radiation like the UV, X-rays or gamma rays, they are neither visible nor they are felt, and those can be observed with special equipments. So, this is called the electromagnetic spectrum. So, if you see this electromagnetic spectrum consists of this the wavelength is here, the wavelength is decreasing here, wavelength is decreasing and the frequency is increasing. Okay. So, it starts with radio waves, then microwaves, then infrared, then near infrared, then visible light, then ultraviolet, X-rays, gamma rays. Okay. And basically this visible light, that is what we get in our atmosphere, or in our earth we get this visible light, and here this all this the different categories of whatever category like radio waves, microwaves, basically their nature is the same, that is the wave nature, but their characteristics are different, that we will see. That is how a microwave is different from ultraviolet rays or the X-rays in terms of their interaction with this spacecraft. Now, we will see this is important just to see what is the the atmospheric absorption of the electromagnetic spectrum. This slide probably I showed you earlier also. So, here if you see all those frequencies, that is this spectrum of that is the gamma rays, X-rays and ultraviolet rays, they are blocked by the upper atmosphere. So, these are these are in the atmosphere, but we are putting the spacecraft above the atmosphere. So, basically your spacecraft is exposed to all those the gamma rays, X-rays, and they come from the sun, and other sources are the sources are also there where from you get all this radiation. Then comes the visible light. So, visible light where after some the atmospheric distillation you get it, and this infrared this is the spectrum you cannot get it, whatever from the sun and the other sources we cannot get it from the atmosphere. Only which is transparent to the atmosphere, it is the this portion, that is the radio waves. So, it covers not only radio waves, but even the microwaves and also. When you go the higher and higher the wavelength, so what is happens, it starts getting attenuated, because this atmospheric attenuation it increases when the frequency is increased or wavelength is reduced. Okay. So, this is for various there is some range of frequencies which you can it is possible. So, all those observations or the communications we do like astronomical observations or satellite communication with these in this frequency bands where it is possible to do. But very long radio waves that we cannot use, this is because the atmosphere. So, it gets reflected from the atmosphere, the ionosphere. So, ionosphere depending on what is the charge density, it will have a maximum frequency. If it is below that, then it will be reflected back. So, this is the reason you cannot do this space based communication at very or you cannot suppose there is some radiation, something is a very low wavelength, very long wavelength. So, then you cannot observe those things because of the ionosphere. So, that is why I discussed that slide. So, the space radiation, it is different from the radiation we experience here on the earth. So, here in the earth basically you are having the visible light and some the radio waves. So, that too some frequency bands which is we are exposed to those type of radiation. But the radiation environment, this is the orbital radiation environment is it is a complex combinations of various types of there is the fast moving ions derived from all atomic species found in the periodic table. So, basically those particular moving ions they will have very high energy and their velocity is almost comparable to that of light, and this constitutes very there is the radiation, that is the space which we do not get on the when you are on the earth, and the energy spectrum of each ion species is varies widely, but prominently this is the range. It can be even lower and it can be higher, it can be even the giga electron volt also, but mainly this is the where the prominent is wavelength is this is the or the energy range, this is the energy range of those, that is the energetic ion species. So, this space radiation it is, as we are discussing, it is comprised of the atoms in which electrons have been stripped away. All the electrons have been stripped away as the atoms are accelerated in the interstellar space to speeds which approach the speed of light. Okay. So, the particles which are very high energy, there the velocity will be very high and it can be that is a fraction of this, that is the speed of light. So, those particles they form something like the beam. So, that is why it is called the that is the radiation in the, or it is other name is also called the corpuscular radiation or the particle radiation. So, this space radiation is made up of three kinds of radiation. The first one is the particles trapped in the Earth's magnetic field, that is called the Van Allen belts trapped radiation. So, we have seen there are two belts and we discussed how the radiation belts are formed, how the particles are trapped and then they cannot come out because of the magnetic mirroring effect, all these things we discussed. So, here these particles have higher energy level. So, this can it acts like the radiation. So, their particles energy is very high, and again this is a function of the the solar cycle, and if solar maximum they will have the during the magnetic storm and all these things, there this there the energy levels, all those things they changes accordingly. Then the second source is called the galactic, that is from the source is galactic cosmic rays. So, the galactic cosmic rays which are the very high energy protons and heavy ions, and these are from outside our solar system. We will just discuss in the subsequent slide where from this the galactic cosmic rays how it is produced and how it couples to our this is the Earth space. Then the particles which are shot into space during the solar flares and coronal mass ejection. This is called the particle events, that also we discussed in our first module. So, during very strong the solar flares, some particles they can get the such a very high energy where this particles is again there the velocity is very high, that is the kinetic energy is very high. So, they also constitute the this corpuscular radiation, or this form the space radiation. Now, the first two sources, that is the radiation belt and the galactic cosmic rays, they are this they are relatively constant, that is that have times change, that is a time scale, long time scales. But the third one, since it is related to solar flares and coronal mass ejection, it is highly temporal. So, this cartoon it shows whatever I said. So, you see this is the sun, and here you are having the solar energetic particles, and you see this the different proportion is showing like positron, then helium. So, the helium is basically all the electrons are the stripped, then it is high atomic mass, high energy, those particles they are having 2%. And this happens it happens, it is temporal, it will not happen continuously. Then the galactic cosmic rays, the source of the galactic cosmic rays are nova or the supernova. So, this those the stars which are out other than our the sun. So, because of the collapse of the stars, there is enormous energy is released, or because of the collapse or the collapse of the core of that star. So, this gives rise to very high energetic particles, and they take a long time scale to enter to our Earth's space. So, you can show that it is entering here, and they also contribute to our the Valence belt radiation belts. And then the third one, you see this is the radiation belt. So, there is two radiation belt that already we discussed, that is outer radiation belt and the inner radiation belt. In the outer radiation belt, this primarily that is high energy electrons, whereas in the lower that is the inner radiation belt, the protons are the predominant. So, we will see that is this all these kinds of the space radiation, whatever we discussed, they are the ionizing radiation. We will tell you what is ionizing radiation, what is non-ionizing radiation, but this whatever the galactic cosmic rays or all these things are ionizing. Ionizing means they are capable of making a particular atom, or it can be molecule, to take out the electrons from it and making it a ionized. So, that is why it is called the ionizing radiation, they are having sufficient energy to do that. So, here the high energy radiation environment is assumed to consist of electrons with energies greater than 100 kilo electron volts. So, this is important, and protons or heavy ions with energies greater than 1 mega electron volt. So, this is also something to be remembered, that is the protons, they are the heavy ions or the heavy ions, their energy should be the greater than 1 mega electron volt, then those are called as the they comes under the radiation, and the electrons it should be 100 kilo electron volt. So, in general any energetic particle, whether it is electrons, protons, neutrons or heavier ions, where the velocity is very high, it is comparable to the velocity of light or a fraction of the velocity of light. So, there this gamma rays, X rays, they can be considered as radiation. So, this radiation, this it can move through the matter, and by that it may displace or ionize the material, which just I told in its path, and when it does that. So, this affected this can be device or it can be a subsystem. This may cause further the disruption or the further anomalies. We will discuss in detail what are the effects of the space radiation on our spacecraft. So, this results in the degradation of the bulk material properties. Of course, there are other types of, this is one, that is the degradation of the bulk material properties. There are some terminologies to explain all these things. We will be discussing one by one when we proceed further. So, the radiation damage, it may decrease the power output of the solar arrays, may create spurious signals in the focal planes of the the focal planes of various type of those quasi optical or the optical systems, and it may also induce a single event phenomena that also we will discuss. This is called single event offset, we will be discussing it, and this happens in all the spacecraft avionics. And this energetic particles, they have the capacity to cause interactions throughout the spacecraft interval, that also we will see in detail. Something we discussed in our plasma environment, that is called the internal charging. Here this the effect will be different. We do not call it the charging, but it directly we will see it how it is different. So, so that is why the radiation environment, to study radiation environment is also equally important, like the other environment we studied different aspects. So, we will see one by one all those things. Before that, just let us introduce what is all those this so apart from as we said this high energetic particles, even the trapped radiation belts, they also contain the energetic particles, and they are mostly electrons and protons. So, electrons are predominantly present in the outer belt, whereas the protons are predominant in the inner belt, and they are confined to gyrate around the Earth's magnetic field line. So, this part already we discussed how it happens, whereas the that galactic cosmic rays, how they are different. They are energetic nuclei, where all the electrons have been stripped off from the atom. So, that is why they are mostly the protons, and they are originated outside our solar system. As I said, it is because of the nova or the supernova phenomena. And GCRs are produced either by nova or the supernova. Already I said what is nova or supernova. Nova is the temporary, means it is sudden brightening of the of a star, and then it goes back. It can be an explosion, and then it restores, but when a supernova happens, the star collapses. Okay. And this solar energetic particle events, that is also called the SPs or SEPs, they are the energetic particles. There also it is mostly protons that are emitted during the coronal mass ejection and solar flare. Okay. Now, there are other types of also particles, that is called the alpha, beta and the gamma particle. They are also that is the radiation, like we have seen that gamma rays. So, it depends on the nature of the radiation that was emitted. So, you can call it either alpha radiation, beta or the gamma, depending on what it is the type. So, basically alpha particle is helium nucleus, and beta particles can be either electrons or positrons. So, positron is it is having its mass is same as that of electron, but its charge that is it is having a positive charge. So, it is a subatomic particle, and the gamma rays are energetic photons. So, these are the the difference between what is alpha, beta and the gamma particles. In addition, already we said that is the protons, neutrons, heavions and X-rays all can be considered in the different types of radiation. Now, you see already we in the previous module we said the plasma, and there also we said it is a charged particle. So, it is required to say how a plasma is different from those radiation particles, they are also the charged particles. So, plasma is a state of matter, it is we call it the fourth state of matter, where it is a gas, where all what the particles can be fully all the particles are fully ionized, or it can be partially ionized also. Okay. So, it means that they have lost or gained the electrons. It is not that all the electrons are stripped away, it is just a nuclei, it is not like that. Plasma is basically it is the electrons and the ions, whereas the radiation it refers to the emission or transmission of energy in the form of waves or particles. So, this is the different, where it is the state of the matter, but here the energy is transferred because of this that is the movement of very high speed or high energy particles movement. So, this is the difference, main difference between the plasma and the radiation. Now, a plasma is a collective group of charged particles, that already we said, that is the collective behavior of the charged particles. like the collective nature of the gas, it is the similar to we discussed the velocity distribution, plasma Maxwell distribution, then we consider the thermal equilibrium. So, we considered it like a gas particles. So, it consists of both the positive and negative particles, and there has to be enough particles present in the volume, so that they interact in a collective way, that is very important. So, if a space object, that is as you remember, we are calling the spacecraft as a probe, you are inserting a probe in a plasma environment. So, if a space object meets a plasma, the plasma particles will move to shield the electrical field from the spacecraft or spaceship, so that the field is 0 inside the plasma, which is called the device shielding. Yeah. So, this part also we explained and we discussed, I think, yeah, we in the last session we discussed. So, how this shielding is formed, how the device shielding is formed around the probe. Now, radiation can be single particles of either positive or negative charge. So, that we already, it can be an isolated very high, like we have seen that it can be electron of the something energy higher than 100 kilo electron volt, and the protons or the heavy ions, it can have the more than the mega electron volt. So, it can be the positive or negative charge, it can be electron or it can be a proton or can be a nuclei, and it can be photon also. There is no collective behavior, means whatever this we said the device shielding, the same thing will not, if you put a spacecraft only in radiation environment. So, you will not have there this type of the shielding. So, but you can get radiation from a plasma, that is possible to have. Plasma can produce radiation when excited atoms release energy in the form of light or other electromagnetic waves, that is the cyclotron radiation that already we discussed. And also the radiation, also the high energy particle, that radiation also can ionize atoms and turn into them the plasma. So, there is no similarity here. We discussed about what is this similarity, but radiation plasma can also produce radiation, but there this getting that radiation, that intensity will definitely, it will not be like what you get very energetic particles radiation. So, although the plasma can produce and emit radiation, but it is not considered a form of radiation itself, because for radiation what I need, suppose as we have seen, that is this all the processes, they are basically they are the slow process. So, there is you cannot expect very that is the fluctuation of the magnetic field is not so high, that is temporal variation. So, that it can produce electric field and like a radiation. So, that is why this plasma itself we cannot call it a radiation, because radiation is a type of energy where plasma is the state of matter. So, examples of plasma, that is the sun's corona or the solar wind we have seen, then the lightning, the neon lights. Examples of radiation include X-rays, microwaves, gamma rays. So, both plasma and radiation can also be found in nuclear reactions. We have seen it, that we discussed how in the stars, in the core, how this this nuclear fusion or nuclear reaction happens, and where from this plasma, both plasma and radiations are produced. So, basically just today I just wanted to introduce the radiation. So, we defined what is the radiation, and we defined it in a different categories, like it can be electromagnetic radiation, it can be very high energy particle radiation like X-rays or the gamma rays, and then where are the other sources also, it can be our radiation belts, where also you can get very high energetic particles which can act like the radiation, not like the plasma, and can cause those effects which a radiation environment does. So, in the next class we will go further, and we will see that is how the radiation environment it affects the spacecraft performance, and we will just see that is how it is different from the plasma environment. In fact, a spacecraft it will not see separately a radiation environment, it will see all the environment together, but in order to understand this thing we are studying each environment separately, and when at the end when we will discuss the satellite operation in the space environment or space weather, we will consider this a satellite operation in the space weather, where we will consider all the environments whatever we will study. So, thank you very much.